I would recommend everyone to have a notebook with you. Okay. So good evening everyone. Welcome to Physics by Aryan channel. I am Aryan Mehra. Okay. I have done MSc Physics from IIT Delhi and now I am a PhD student at IISc Bangalore. Okay, so we are doing quantum mechanics in 3 dimensions. Why we are doing this topic? Because this topic is little bit hard to understand by yourself. Number two, this topic is extremely important for all kind of exams. For example, it is very much asked in JEST, it is asked in GATE, it is asked in CSR NET, and also in TIFR. So yesterday in the lecture 1 for quantum mechanics in 3D, we discussed how to think in terms of quantum mechanics, what are the states, what are the operators in quantum mechanics, and how you can get started with the thinking in quantum mechanics. Okay, today we will officially do the topic in quantum mechanics in 3 dimensions. This topic comes into picture, the number one problem that comes into play is hydrogen atom. If you do understand hydrogen atom very well, you have almost understood what is quantum mechanics in 3 dimensions. Hydrogen atom is something which contains a nucleus. One nucleus is there in which there is one proton. There is no neutron in hydrogen. So one proton, which we can also call it as proton, or you may call it as a nucleus. It's up to you. And there is one electron also. So two body system, and we deal with this quantum mechanically. So far you have not done it quantum mechanically, and I will not solve it entirely quantum mechanically, but I will give you the summary, whatever you need from this entire set of big derivation which is been taught in all the MSc courses and in books and so on. But out of that entire set you need a very small things. So let's do it. So whenever we say we want to solve any problem, what is the number one thing that comes into mind? If you have taken yesterday's lecture, you know, if we want to know about the system, we need to solve the Schrodinger equation. Why? The Schrodinger equation gives you the wave function, which we call it as a state of our system. What is the system here? Hydrogen atom. So we will write the Schrodinger equation for hydrogen atom and then solve it to get the wave functions to know what are the possible states of our hydrogen atom. So if I recap you a little bit, you know, you have a nucleus. Let's talk in terms of Bohr model. However, in quantum mechanics, Bohr model does not work very well, but you can imagine in terms of Bohr model. What are the states? We know the states are n equals to 1, okay, L equals to 0. This can be a one state. Okay, if I have n equals to 2, then you can have either L equals to 0 state, or n equals to 2, L equals to 1 state, n equals to 2, L equals to 2 state. Okay, do you all agree with me that these are the possible states in the quantum mechanics in the hydrogen atom? Okay, so this we want to know actually from the derivation of quantum mechanics, what are these quantum numbers? Okay, and what does this state actually representing? How do we come up to these states? When I am again and again saying states, yesterday we discussed in the length, when I say state, we means some physical parameter. If it is n equals to 1, L equals to 0, if you will measure its radius, it will come out to be something r1. Then you say okay, it is in n equals to 1, L equals to 0 state. If it come out to be r2, you say okay, it is in n equals to 2, L equals to 0 state. Okay, or maybe you can do the same thing by energy. If you measure an E1, then you say it is in state n equals to 1, L equals to 0. Similarly, if you measure energy E2, you say okay, it is a n equals to 2, L equals to 0 state. So something like that we say. We never measure quantum numbers directly. We measure some physical parameters, and let's say energy. We always do mostly in case of energy. Okay, and then we say okay, if energy comes out to be E1, then I am in state 1. And what is state 1? State 1 means my n is 1 and L is 0. If I measure energy E2, then what does it means? I am in state 2. What does state 2 mean? State 2 means my n is 2 but L is 0. So this kind of things we say. But these quantum numbers should come up from some derivation or maybe some sort of thinking that comes out from the solution of the Schrodinger equation. So now let's make this session little bit interactive and see, do you all agree with this Schrodinger equation which I have written here? Minus h cut square by 2m del square phi. So can you tell me what term is this? What is the name of this term? Hmm?
Kinetic energy.
Yes, so it's a kinetic energy term, and V phi is potential energy term, and E phi is energy term that we discussed yesterday. Now, if we want to solve anything in 3 dimensions, something like hydrogen atom, and if I give you an example, options, you can either solve it in XYZ direction, taking the coordinate XYZ Cartesian, or you may take the cylindrical coordinates or spherical. What do you think will be more appropriate to do?
Spherical polar.
For something like hydrogen atom. Yeah, but do you
Spherical
think?
polar coordinate.
Yeah, it's good, but why?
So because hydrogen atom is assumed to be a sphere.
In which theory?
According to Bohr's model.
No, Bohr model says it's a circular orbit. That's okay. But let's assume we don't know it's circular. Then why we are taking actually r theta and phi? Why we take spherical polarity? From where you got an information that okay, atom is actually spherical. It's not spherical. That's 100% sure. And spherical polar coordinates. Yeah. Yes.
Because of symmetry, do we take it?
Which symmetry?
The spherical symmetry.
What is spherical symmetry? Yeah. How you know it's spherical symmetry?
Quantum
You are
model
right.
about the shape of the s orbital, which is spherical.
No, but, there should be some equation which gives you an idea that okay, it is spherical. Beforehand, before you start. Okay. So out of these 3 terms in the Schrodinger equation, but which term do you think is actually will tell you about the symmetry? Okay, so let me.
The phi.
No, so okay, let me simplify the things for you. Let's say you have a ball, okay, and force is in one direction, either x, y, or z. Okay, and it is you need to write the Maxwell's equation. Oh, sorry, Newton's laws equation. Then what do you think you should know about? You want to know about the direction of the force. If it is along x, you will write the equation in x. If it is along y, you write the equation along y. If it is along z, you write it along z. Do you all agree with me?
Yes, sir.
So what is the counterpart of force in our Schrodinger equation?
Hamiltonian.
No, Hamiltonian is nowhere in this equation. Hamiltonian has already been, yeah, but someone said potential. Do you all agree that potential is a counterpart of force? Because you can write this equation. Do you all agree?
Yes, sir.
Yeah. So now tell me what is the potential for hydrogen atom problem? Very simple. What will be the potential if proton is attracting electron? Yeah.
Coulomb potential.
Yeah. What is the formula?
K Q1 Q2 by R minus.
So you are saying minus K E square by R. Do you all agree? Everyone agree with Sahin? Is it a correct formula to write? Is this the potential between proton and electron? Tell me very quickly. It's very simple thing.
Sir, not E square. Sir, only E.
No, no potential
Only
energy
R
है ना.
square.
It's a potential. Are you sure there is R square in potential?
No, sir, it's R.
R.
R. Only R.
Yeah. Yeah. And second thing, it should be E square. The reason being, it's a potential energy, not potential. Okay. Because kinetic energy, if you want to add it to kinetic energy, then you need to add potential energy. You can't just add potential to kinetic energy. So this is a correct formula. So from this formula, do you think it tells you that it's spherical? From this equation, do you have any idea that it is spherical?
Yes, sir, because R is like it can take any direction and just like a sphere.
So it's like a radial symmetry. For example, what is the radial symmetry means? Let's say I draw a sphere of radius r. Okay, radius r. Then on all the points on this surface, the potential will be same because r is same everywhere. It means what kind of symmetry it is? Spherical symmetry. So that was the reason why we started using r, theta and phi. Okay, so do you all understood why r, theta and phi is the best option?
Yes, sir.
So do you
Yes, sir.
got the chain of the thoughts? Okay. The reason being, what happens is everyone knows hydrogen atom problem. Maybe you might qualify the exam also, but in interview, these kind of questions, they when they start asking that there is a problem. Okay. So this is an equation, and now since it's a spherical symmetry, so now let's start doing r, theta and phi. Now there is some mathematics written, which is just written. There is no use of this mathematics, which I will do it today. So del square is written like this in r, theta, phi. Have you ever seen, not remember, but have you ever seen del square written in this form ever?
Yes, sir.
Have you seen this? This
Yes, sir.
ugly equation, have you all
Yes.
seen this? Yeah.
Yes, sir.
Yes,
So
sir.
so don't care about this. Okay. So now let's move forward. So this will be a Schrödinger equation. It will become, we don't care. Okay. We care how to solve it. How to solve this mega problem into a small problem. In quantum mechanics, always remember, we always use separation of variables. There are three variables here in our hand. One is r, one is theta, one is phi. So whenever we start to solve quantum mechanics problem, we say, okay, this is our total solution. Phi is our total solution, state of our system. Now it depends upon three coordinates, r, theta and phi. Very good. Now let's break it down. So one is radial part and another is spherical harmonic part. We call it as spherical harmonic. Okay. So one part only depends upon r and another part only depends upon theta and phi. So we can do separation of variables. You may ask that maybe separating the variable is not possible. If it is not possible, while solving the problem, you will understand, okay, it's not working out. Okay, you don't have to worry in before. So it's like a mathematical tool of physicists. First, whatever thing what they do is whenever they have complex differential equations to solve, they split their total solution into the two solutions or three solutions containing different variables. So that's a number one thing. So now my total solution is a combination of two solutions. One is radial part and one is spherical harmonic part. Radial part is represented by r. So it will be some function of small r, and y, and spherical harmonic is written as y. Always remember, not just in not just in hydrogen atom, in any kind of spherically symmetric potential. Okay, I want you to remember this line very fondly. In any kind of spherically symmetric potential, can you name any other spherically symmetric potential?
The central force potential.
Yes, center force potential is also one of this. Okay, so in any sort of spherically symmetric potential, you will get a solution in terms of spherical harmonics. Always. Okay, because your force is not changing anything along theta and phi, because force is not along theta and phi, it's only along r. Okay, so you have to get a solution in terms of y, theta and phi. Okay, so that's what one thing is. So now let's see what these spherical harmonics are. You don't need to actually worry about how to solve this, how to get these spherical harmonics, but you only need to know that what these actually are. You don't need to worry about the derivation, how they come across and actually come to the point where they derive these spherical harmonics. That's not your tension. Now let's go into one more step. So when we are talking about spherical harmonics, it has two parts. One is theta, one is phi. Now let's split that also. So theta part is written as theta under the two lines, which you can, any symbol you can give, but I have given this simple symbol. Griffiths has also given the same symbol. Phi you can also write. So I have split my total spherical harmonics into two parts. Very simple. Okay. Now the number, another next thing you should know is that your phi part is nothing but e raised to power iota m phi. This is a very simple thing which every one of you can easily know. Okay, you don't have to worry about the derivation. I don't want you to derive that it is e raised to power iota m phi, but you have to remember that it's e raised to power iota m phi. Okay, if you say I'm asking you to remember things, then don't worry, then you can go and see the derivation, but that's not important for you. That's why I'm saying don't worry about it. So your phi is e raised to phi part is e raised to power iota m phi. Now let's see what's your theta part. Now what is m here? M is a number one quantum number which have came. All of you must have remember in hydrogen atom, number one quantum number is L, number two quantum number is L, then third quantum number is M. Do you all remember this?
Yes, sir.
You remember this N, L and M, three quantum numbers in the hydrogen atom? No one remembers this?
Yes, sir.
Do you all remember, or I should repeat? N, L, M, M. Three quantum numbers. Okay, let's repeat very quickly. You guys are seem lost here. So if n, what are the values n can take? Let's recap in quantum mechanics. Can anyone tell what are the values which n can take?
Sir, 1 to infinity.
1, 2, 3, 4, etc.
Okay, and what are the values which L can take?
N minus 1.
Okay, so if n is 1, what is the L?
0.
L is 0.
Okay, if n is 2, what is L?
0, 1.
0 and 1.
0 and 1. Okay, all of you all are with me. If n equals to 3, then what is L? If n
0,
is
1
3,
and
what
2.
is L? 0, 1, 2. Okay, so all are with me. Okay, so this till here you got. Now let's see, talk about M, ML. Okay, M or ML, you can say anything. Okay, so if L is 0, then what is M?
0.
Let's say L is 0, then M is 0. Okay, so if L is 1, then M is
1, 0, minus
1,
1.
0, 1.
okay, minus 1, 0, 1. So do you all know this much? I expect you to know this much because you all have done class 11, 12. Okay. Do you all agree with me this much? Yeah.
Yes.
Show some
Yes.
response. Other people who are speaking other than
Yes.
those. Great. So if you know this much, yeah. So if you know this much, then let's move forward. So number one quantum number has came to you. M is came. So M is a quantum number which is associated with the phi. And yesterday I said any quantum number or any quantization comes because of, can you tell, because of?
Boundary conditions.
Yes, quantization comes because of boundary conditions. So what is the boundary condition which was there so that this M came? This M came because of the symmetry in phi. So let's say you have a sphere. Okay, so if I have some solution on this point, whatever is a value here, okay, if I take a complete one turn and then again come back here, my solution should be same. So whatever my wave function is at phi, it should be same at phi plus 2 pi. Do you all agree? It's a very simple boundary condition. Whatever is my value at phi, it should be the value at phi plus 2 pi.
Yes, sir.
Agree?
Yes, sir.
Yes, because it is circling back to the same point. So if there is a boundary condition, then there must be some quantization, and because of that boundary condition, m quantum number has came. This much information you need out of entire derivation. Now moving to what is your theta part. Now your theta part is actually not as simple as e raised per iota m phi. It's not that simple. Okay, so you can't say okay this your theta part is actually in terms of associated legendary polynomials. So if you try to do the derivation, then you have to solve, if you must have remember differential equations whose solutions are in terms of special functions. Okay, so that much derivation you have to do to actually come up to this solution, but we don't care what is derivation, and in fact we also don't care the what is theta part. Okay, but let's read it out. Our theta part is in terms of associated legendary polynomials. A is a normalization coefficient. Okay, PLM means for each L and M value there will be some theta part. So L and M just is a notations. It is a function of cos theta. So don't worry about it. The solutions are in terms of associated legendary polynomials. Only that much you should know. Okay. Now, what is the associated legendary polynomial? I have given the definition for that, mathematical definition. Now, associated polynomials are represented in terms of legendary polynomial. So what is legendary polynomial? Then it is written in mathematically. I have written that. So the biggest mistake which I made during my preparation was actually remembering these formulas. But in reality, in no exam, they expect you to remember these formulas because it's so much of waste of time. Okay, so don't remember these formulas. What is PLM, what is PL, you don't have to worry about it. You only have to worry, you only need to know that okay, what is PLM, associated legendary polynomial, and what is. So my theta part is in terms of this. Now then another thing, second quantum number has come into picture, which is L. Now why L has came, can anyone tell? With what boundary condition is there? Very simple. Why L has came?
So that should be theta plus pi because theta varies from 0 to pi.
Yeah, I when I wrote it, I knew that someone will ask this question. Okay, someone will ask this question. Okay, so let's draw a sphere. So this is a sphere. Okay, so what is theta here? So if this vector is this, okay, so this is theta. Do you all agree? This is that direction. Okay,
Yeah.
so whatever you are saying, whatever value is there on the top up, it should be the same value at top bottom. This is what you are saying.
No, sir. So negative of that because projection Z is along negative direction at the bottom.
Okay, so what will be the value of theta if this is a vector? What will be the theta?
Pi by 2.
Okay, and if I complete if it is like this, then
Pi.
so according to you, if I write theta plus pi, it means whatever value is at the top should be at the bottom. This is what you are saying?
Sir, no, sir. Negative of that because cos pi is -1, cos 0 is 1.
So it is not, no, but there is no cause here, na. I'm saying whatever value is here, but should be the value there. Why you think it is its dependence is like cos? Maybe it's like sine or maybe e something. Anything can be there. So you are right that
solution is cos.
no, you are right. Whenever we define spherical coordinates, we define theta in 0 to pi only. That is your source of confusion. Okay, we define that because defining theta from 0 to pi is enough to encircle the entire sphere. To cover the entire sphere, theta 0 to pi is enough because your phi is taking the entire circle. But when you are thinking in terms of boundary condition, then you have to keep your theta moving from 0 to 2 pi. Na? Entire circle, you have to come back to the same point. So there is a difference between what is boundary condition and what we define in our spherical coordinate. Do you understand what I'm saying? That.
So if phi is completing the entire circle, then why don't we like take theta from 0 to pi? Because if the circle is completed by phi.
No. See, let's say I'm not looking at phi at all. Okay, I'm fixing the phi. So along this curve, I am coming to this point. My phi is fixed. If I'm coming along any one of the curve by keeping my phi fixed. So do you think the value of theta here and there should be same? No, na. Value of theta nahi. Value of your function. Value of your function should be same? No. Your value of function should be same and you entirely come back to the same point. Okay, theta we define as 0 to pi in spherical coordinate, but in boundary condition is theta and theta plus 2 pi. At these two values, your function should be same. So boundary condition and how you define your spherical coordinates is both are different things. That's what I'm saying. Okay. Now, so this quantum number L has came because there is a boundary condition in theta. So that is why your second quantum number came into picture. Now, what you need to know, if I am saying don't remember this, then what is the point? What from where question actually comes? So the question actually you need to know is, if I give you spherical harmonics, then by looking at those spherical harmonics, you should actually know that what are the quantum numbers. So it's actually a reverse engineering that you should know, not a direct derivation. So this this I think you all have covered that what is spherical harmonics. It's a combination of two, theta and phi part. Theta is something in terms of associated Ladender polynomials and phi is e raised per iota m phi. Okay, so main thing to know is if I give you, so for example here we see, if I give you the spherical harmonics, can you tell me what are the quantum numbers which are required? So that you will learn, and it's quite simple to learn. Okay. Just a second. Screen is, I think, not moving. Give me a moment. Any questions so far? You all got the idea what is happening here?
Sir, we need to normalize the phi part also. There will be 1 by root 2 pi factor in the spherical harmonic.
Yeah, there can be many normalization constant. If you start normalizing, then you have to normalize theta part also. Okay. So I'm saying don't worry about those things. You function will be given to you normalized. Okay, function will be given to you. You only have to know what is the quantum number. So can you all see the screen very clearly? Image?
Yes, sir.
Okay, so here we will see if by looking at this, how can we actually know what is quantum numbers? Currently, we are not talked about the radial part. R part, we haven't come yet. We have only discussed about spherical harmonics. So let's first learn that. So you know phi part is e raised to power iota m phi. So this m will give you the value of m. So in first part here, what is m? Can I write it as e raised to power 0? 1 can be written as e raised to power 0. So what is m here? M is 0. So do you see 0? It's given. Oh, sorry. Yeah. So sorry. It's 0 given. Upper part is L. So it is y L m. So upper part is m, lower part is L. So 0 is given. Now again here also you can write e raised by 0. So m is 0 here also in second. Now in third, what do you think? M is either plus or minus 1. So do you all agree?
1.
Yeah, everyone understood?
Yes, sir.
All other people?
Yes, sir.
समझ आया?
Yes, sir.
Yes, भैया.
Okay. So in now this again 0 e raised by 0, there is no phi part in it, so e raised by 0 is there. Now in again plus minus 1, here you can see it's plus minus 2. Okay, so in this way you can know what is m. So m we know, m is very simple to know. Okay, so now let's rub this down and now let's find L. Okay, so remember L is the number of cos terms or sine terms. Number of cos terms plus number of sine terms. Okay, so how many cos or sine terms are there in this first equation?
0.
But how 0? So what is L?
None.
0. In second, how many are there?
1.
So it's 1. In third, how many are there?
1.
1. In fourth, how many are there?
This is cos square, so we can take 2.
In fourth, how many are there?
So 2.
Hmm? How many of you said 2 and how many of you said 1? Huh?
2, sir.
2. Because cos square theta can be written as cos theta into cos theta. So there are 2 terms. So L is equal to 2. Now in fifth term, 1 is sine term and 1 is cos term.
2.
So again L equals to 2. So similarly you can find for all. It is very simple. Very simple idea. Okay. And you
So
can
the
match.
L value.
Hmm?
So the L value will then depend on number of sine and cosine terms.
Yes. How many number of sine and cosine terms are there? Add them. That will be your L. Okay. It's a thumb rule. Okay. So if someone gives you spherical harmonics, let's say I give you any spherical harmonics and I ask you what will be that. So then you can easily find that. So now let's practice this. Now let's practice this. Can you all see the question?
Sir, I have a doubt.
Tell me.
Sir, in the previous slide that y03 there is cos cube theta and then another cos theta, but it is written 3, L equal to 3.
Okay, good question. Good question. Let me come back to that. 5 cos. Okay, just let the screen move. Because of the heavy rain here in Bangalore, there is some problem in internet today. Okay. Yeah. Okay, so this term you are asking, this one, this one, okay. So you are saying that this 3 is written, but actually 3 plus 1, 4 terms should be there. Okay, so now I can change your mind. Okay, so let's take cos common. Okay, or maybe just wait a second. Sin theta 3. So this what happening here is, if you see this fourth number equation, 3 cos square theta minus 1. So in this term there are 2 terms, but here there is nothing, 0. It's a sum of the 2 values. It's not single thing written. So if you have added 2 here, then you can't consider another term which is there. You can't consider it. You can't add these 3 terms. You have to see if it is a sum of 2 terms, then you have to see what is a maximum one. That's a simple thumb of rule. That I forgot to mention this. If it's something like multiplication, sine square theta into cos theta, then you say okay, it's 3 terms. 3. But if it is like sine cube theta plus cos cube theta, then you can't say it's 6. It is still 3. Okay. So good observation. Otherwise we would have missed that. So I would like you to all to go through this table, find L and ML for yourself and get convinced that okay, this rule works. Okay. If you can do this for this table, then you are good to go. Okay, so now let's come to one question which is very good, important question. It's asked in TIFR, so it's a TIFR previous year question. So in this you need to find L and M and N. So don't worry about N yet because I haven't told you about the radial part. So let's only focus on L and M. So I have hidden all the 4 options, so you don't know what is exactly the option. So can you tell me what is the value of E here? Oh, sorry, M here. So you can write it down exponential terms as
1.
e raised, yeah, e raised power minus a naught, e raised power minus iota phi. So you can write it like this. So can you tell me what is the value of M, everyone?
Sir, -1.
Minus 1.
Minus. So which option should we write then?
Sir, C.
B. Oh, sorry, C.
There is only one option which can be correct if it is -1.
Yes, sir, C.
C. Now the problem here is C is correct. C is correct. But can you imagine in TIFR exam you are solving this problem? Okay, your answer came out to be -1. First thing that you will do is -1. Now TIFR given 2 options for 1, M equals to 1. And what is your natural tendency? You will think no, M should be 1 because there are 2 options given for M equals to 1. Do you all agree? It's how much TIFR wants you to get confused. In JAM, what happen or in JEST what happens? If answer is M equals to -1, in 3 options at least M equals to -1 will be there. So you are sure that M is -1. But here if your M comes out to be -1, you will think no, M maybe is 1. So be aware in TIFR exam. Options are very. Don't read options too much in TIFR exam. Remember this. In all other exams you can read the option, they help you, but in TIFR exam they go against you. Okay, now moving to next. What is L?
Sir,
2.
2.
2. So L is 2, M is -1. So option C is correct. Do you all agree with me? So TIFR question, this is a TIFR PYQ. So let's see, now remove it. So C is the correct option. TIFR also has given option C is correct. Okay, so now we will do one more question, which is little
How
bit
did the n equal to 3 came?
Yeah, that I will teach you tomorrow, that how we find the radial part and how we know the n. Okay, don't worry
Okay,
about
sir.
that today. Today we only talk about spherical harmonics. We haven't added the radial part yet. Now let's move forward and let's see this question. Now there is no r, no theta, no phi. What you will do? Don't read the question. Just I am asking you to what is the theta and phi, what is n and l in this. Oh sorry, L and M in this. I don't want you to solve the
Sir,
exact
M
question.
is 0.
L is?
Sir, M is 0.
M is 0.
And L is
Okay.
2.
L is 2. Why? Why L is 2? Or M is 0? Huh?
So we can write this in spherical
Yes,
polar
yes,
and then
yes.
separate the phi and theta
Yes,
parts.
you first have to write this in terms of spherical harmonics. Oh, sorry, spherical coordinates. So what is x in spherical coordinates?
R sin theta cos phi.
R cos.
Okay. And what is y?
R sin theta sin phi.
R sin theta, R sin phi.
Okay. And 3r
Z,
cos it.
Z is R.
Okay. So this is the thing. So now let's take r common, and your final term is sine theta cos phi, sine theta sine phi. Now there is a one very big mistake which you can do here. Okay, don't add these two terms as sine and cos. Okay, why? Because one is in theta, one is in phi. For phi you need e raised to power iota term. Okay, always add theta, sine theta or cos theta terms. Okay, so first we need to write this in terms of phi. So can I take sine theta common from first two terms?
Yes, sir.
Okay, so do you all know these formulas? I think everyone everyone here will know this, no? All of you know this?
Yes, sir.
Yes, sir.
Yes, sir.
Can you correct me if I'm wrong? Here 2 iota is there, no? Or only 2 will be there?
In sine term, that's 2 iota.
Okay, so it's correct
So
now,
it is
both
correct.
of these. Okay, so now let's put it there. Let's go up and just put it. Okay, so
that should be cos phi and sin phi.
that should
Yes.
be
Sir, when you take the sine term
Correct.
as common,
Yeah,
the
cos
first
phi,
term will
yes.
be cos phi.
Cos phi sin phi, yeah. So e raised per iota phi, e raised per minus iota phi plus by 2 e raised per iota phi minus e raised per minus iota phi by 2 iota. Okay, plus 3 cos it. Now this much information is enough to know. Can you tell me something about this state just by looking at it? Okay, we can do one more thing. Just separate out the phi term and minus phi term. Okay, so that will make out things very simple for you. So how we do that? Okay, sine theta half 1 plus 1 by iota e raised per iota phi plus sine theta by 2 1 minus 1 by iota e raised per minus phi plus 3 cos theta. So do you all agree that this is something we have a state?
Yes, sir.
I have a question that if we expand the cos theta, and will there be the exponential will be also in e raised to I theta plus e raised to minus I theta by 2?
Then we don't expand theta terms. We need sine theta cos theta.
Okay, sir.
We need e raised per phi something. That is why we have expanded phi terms, not theta terms.
Yes, sir, but there the expansion will be cos phi is equal to e raised to I phi plus e raised to minus I phi divided by 2. When you write the expansion as cos phi is equal to e raised to minus y.
Yes, this is what I wrote, na? Sine theta is there. This sine theta
And you
is
have
sine.
written theta.
Sir, you written theta instead of
Sir,
cos
in the
phi.
formula, sir. Cos
Formula,
theta.
sir, yes.
Okay, in the formula. Okay, sorry for that. It was phi is there. It's very simple. Okay. So this we have came. Now this is not an individual term. Okay, it's not like that. This entire wave function has only one L, one M, and one N value. It is actually a superposition. So there are three terms. So what do you think is first terms L and N? L and M.
Sir, 1, 1.
1, 1. Yes, sir.
Okay. Second, so there is some constant A, there is some constant B, and it's for second term, what is it?
1 minus
1 minus 1. And for third term,
1, 0.
1, 0.
1 0. So your final state is something like this. Something like this. Because in quantum mechanics, it is very simple that you know that the state can be a superposition of different states. And this is something which you get. So how many of you understood each and everything till here?
Yes.
Yes, sir.
So
Yes,
you
sir, got
got
it.
that. Okay. Now the second thing which I want to discuss is, actually it's very good point to move to there. What is been asked in the question? Now read the question. The wave function of a particle subjected to a three-dimensional symmetric potential, which we discuss what is symmetric potential, is given by this. So we have found this. Now they have asked the expectation value for the operator is. What is an expectation value of operator? L square. So now let's move on to finding the expectation values. If you know how to find the expectation value, then you can write any operator into matrix form. That will be our next step. But now let's first find the expectation value. So always remember this thing. I have picked these two questions very intentionally so that I can explain everything with these two questions except what we were doing. Okay, expectation value. Okay, so any one of you can tell me how you found expectation value? What is the formula? If I want to find an expectation value for an operator A, first
Sorry,
of all, can
screen
you
is
tell
not
me
on.
what is the meaning of that? What is the meaning of expectation value?
Sir, your screen is, I think, not.
Average value.
Average value. What average value? How you
Sir,
define average?
in the sir, in that state actually. Sir, psi star, then that particular operator, then psi. We have to take
No,
the
I'm not asking for
bracket.
formula. I'm not asking for formula. Let's say I give you a hydrogen atom, which is in superposition of these three states. Means some of it is in L equals to 1, M equals to 1. Some of it is in L equals to 1, M equals to -1. And some of it is in L equals to 1, M equals to 0. Okay, so basically it is in L equals to 1 state, but M is different. So what is the meaning of expectation value then? In terms of
Sorry.
experiment that you will perform?
Is it related to probabilities or?
It's the
So
most probable value, I guess.
if I give you, if I tell you I did an experiment for 10 times, I find the energy of this state 10 times. What is the meaning of expectation value now? How you will find the expectation value from those formulas?
There's the maximum possibility that one can measure or one can expect.
Yes, sir. Most likely.
Okay, now let me ask you one. Let me explain one thing and then ask another trivial question. Very tough question that is going to be. So expectation value is, let's say I did a measurement for the 10 times and then I took the average. Or second thing is, let's say I did an experiment for 10 times and then I saw 4 times one value was repeated, 3 times another value was repeated, and 3 times another value was repeated. Because it is a superposition of 3 states, only 3 values can come. So 4 times value 1 came, 3 times value 2 came, and 3 times value 3 came. This is one case number 1. Now case number 2 is same thing happened, but you take its average and then that is an expectation value. Or expectation value is which value came maximum times. So out of these two, what do you think is the case? Is it an average or which
Average.
average?
No,
How many of you say average?
so it's the maximum value. Maximum.
Average.
So you are saying expectation value is something which is coming maximum number times. One person said that.
Yes, sir.
Okay. How many of you say it's a value which comes maximum number of times?
So which comes maximum number of times?
Okay. So then what is most probable value?
It is the same, I guess.
How do you define most probable value?
That is also same by the same definition.
Okay. Expectation value and most probable value are same.
As per me, I'm not sure, sir.
No, sir.
Okay. So expectation value is actually an average, and most probable value is something which you are saying that which comes maximum number of times. So remember this difference. Okay. Before jumping to definitions, we should actually understand the meaning. So this is a meaning of expectation value. How you define it? Now let's do mathematically, because I am experimental physicist. I always see what's the meaning, then I move to what theoretically. I want to avoid theory as much as possible, calculations. So it is phi, a cap phi. Now
Sir,
the second thing comes is, yeah.
sir, the expectation value, is it the average value you told?
Yes, it's an average value.
Okay, sir. Actually, in Griffith chapter 1, somewhere I read that it's a misleading term and it is not the average value. It's like
Yeah, it's a misleading term. It's not an average value. Why? Why?
yes, yes, sir. That's I, I got confused with that. If you are saying this is the
When
average value,
when you will find it, na, it's average. When you will find, it's actually will come out to be none of three. Neither one, neither two, neither three. Because when you are finding an average, okay, then it can come anything like, let's say you find an average of 1, 5 and 10. Then it will come out to be something either 6 or 7 or something like that. Average will come 1, 5 and 7. If you 8, then average will come out to 16 by 3. But 16.3 is neither 1, neither 5, neither 10.
yes, sir.
So you can never actually measure that value. Can you actually measure 16 by 3? If only three possibilities are there, either you can measure 1, either you can measure 5, or either you can measure 10, but their average is coming out to be 16.3, which you can never measure.
Right.
And you are naming it as an expectation value. What is Hindi meaning of expectation value? If you measure this, if you do this experiment, this is what you expect. It is an Hindi meaning of expectation value. But
Yes.
whatever it is coming, that you can actually never measure.
Right.
So
Okay.
that's in that way it is misleading. You understand?
Ji, sir.
Yeah. But if you name expectation values average value, then it's no longer what you can say misleading, because average value we all inherently understand can be something else. Okay, so now let's move on. So how you find an expectation value of an operator? Whenever I say operator, always think in terms of some physical measurable, because every physical measurable is converted into operator when we do theory. So this is what a very ugly expression another came. This is called direct notation. So what does this direct notation means? So now if you want to understand direct notation, first of all you need to think a vector, a cap as operator, which is it is operator, phi as an vector or state. So this a phi, a is operating on this state phi. Every state is represented in this bracket, which is called ket. Okay, it's just a notation, nothing else. A cap is acting on it. It will give you some value and again give you back your state. Do you all agree? This we did yesterday.
Yes, sir.
Yes, sir.
Okay. Now we take inner product. If you don't know what is inner product in quantum mechanics, I will strongly suggest you to go to Jetly chapter number 2 and read that chapter. You will get more information about direct notation. Okay, since I have already covered this in my course few weeks back, 1 or 2 weeks back, so I'm not covering it again. But simple idea is you are taking its inner product. So you are taking the same state again and multiplying it or it with this state lambda phi. Now since lambda is a constant, it can come out and phi can be done. Okay, so this is what our main idea is. Now let's do so that you can actually understand more when it's in operation. So we want to know the L square. So we have our phi, we have L square, and we have phi. So before I jump into running into solving the problem, I just want to know that if I operate my L square on this state, what do you think will be the answer?
L into L plus 1 times H cross square.
Yes, sir.
Do you all agree with me? Yesterday I told you if L operates on y on some state, the answer is L into L plus 1 under root H cut. And today we have just squared it. Nothing else. So Since
Sir, again
value,
the same wave function also.
uh-huh,
So
yes,
YML.
yes. So again this will come. Okay, again this will come. So first step is to operate our L square on our state, whatever our state is. So what our state is? Our state is this. Now it's very important. We have skipped this, but we shouldn't have skipped this. Uh, we have written A, B, and C, but we should know what is this A, B, and C. Okay, what is this A, B, and C? We should know. But for now, we are not worrying about. But you can easily know what is A. What is A? A is 1 plus 1 by iota, or you can say 1 minus iota by iota. No, 1 minus iota, okay, by 2. And what is your B? B is your 1 plus iota by 2. And what is your C? C is 3. How many of you agree with this? Let's see how fast is your mathematics. How many of you agree with this? Anyone agree?
We are not
No,
including
there is other.
R inside theta term.
No, that theta term. See, theta term is added in y, na? YLM. Okay. Yeah. So see, what I did is I just multiplied and divided iota.
Okay, then that's fine. Yes.
So bottom thing will become negative. So it become 1 minus iota divided by 2. Similar thing I did, multiplied by iota. So it became plus. So 1 plus iota by 2 and 3 comes as such. So now do you all agree? A, B, and C?
Yes, sir.
Yes, sir.
Okay. But remember,
But the radial part is.
huh? Radial part is separate.
Radial.
There is also one radial part. See here, it's also given FR. FR is given. We have not even considered that. Okay, because we are interested in L square. L square does not contain any radial part, no? So we can write it like this, FR. Okay, but I am only interested in Y. So Y does not contain R part. So I have all extracted the Y part out of my total wave function. Okay, so A, B, and C. Now another thing that you should remember in TIFR exam. See, here you can solve the rest of the question by taking A, B, and C exact values. But always remember when TIFR gives you tough A, B, and C values, because see here, it has not given you simply half. It has given you 1 minus iota by half. So that while solving the question, it becomes so hard for you to do the calculations. That's why it takes more time. So always simplify it to ABC and then in the end put the value of ABC. In TIFR exam, remember this. Otherwise your calculation will go so long. So our thing is 1 1. Our spherical harmonic is 1 1, B minus 1 and 1 0. Now let's apply L square to phi. So L square will be applied to Y 1 1. L square will also be applied to, sorry, operator also you should write in terms of operator symbol, you should also put here 1 minus 1, and it will also apply to Y 1 0. So 1 gives me an answer, but what should be the first value?
2h cross square.
What does this give you? You can use this formula.
Yes, sir. 2h square.
2h cross square.
So 2a h cut square is my answer. What is second terms gives you?
Same.
2b h cross square.
Yeah, 2b, sorry, 2c h cut square. All agree with me? Okay. So now I bring in my f and do this to find my final expectation value. Okay. So what is my phi? So this phi is always written as whatever is your phi, just do its complex conjugate. Whatever is your phi, just do its complex conjugate. So it is A star into Y1 star plus B star Y1 minus 1 star plus C star Y1 0. The people who don't know complex conjugate, if your function is 1 plus iota, then its complex conjugate will be 1 minus iota. Similarly, A and B are in terms of some iota. Similarly, Y can be in terms of some iota. So we are just simply doing complex conjugate and multiplying it with L square phi, which we have found here. So I am just taking out 2 h cut square outside. So I will get, sorry, here we should also have written this. Okay. So y1 1, b y1 minus 1, c y1 0. Okay. Now the next step comes. How? So first of all, how many of you understood till here? If you haven't understood till here, then we will move forward. Everyone else, do you got the point? What has happened till here?
Yes, sir.
Yes, sir.
Yes.
Okay. So now let's move forward. So now, have you know what is orthogonal states? Orthogonal states.
Yes, sir.
So if
Product
the
is
two,
0.
yeah, their inner product is 0. So if you multiply 1 star with 1 star 1 it is 1, because they are both. If you do 1 star in with 1 star 1 minus 1, sorry, it is 0, because now the states are different, so they are orthogonal to each other. If I take the classical analogy, let's assume this is I cap and this is J cap. I am doing its inner product. So I cap with I cap will give you 1, but I cap with J cap will give you 0. So how many of you understood this?
Yes.
Yes, sir.
सबको समझ आ गया भाई?
Yes, sir.
If you are not able to comprehend, please read Jetli chapter number 2. सब smoothly समझ आ जाएगा. And if you don't want to read the book, I have uploaded last I have given 4 quantum mechanic lectures in the group. Please watch those. I have explained all these things in detail. Okay, so let's move forward. So this term and this term will stay. This term and this term will become 0. This term and this term will become 0. Then similarly only 3 terms will stay. So I will get A star into A plus B star into B plus C star into C. So you all got that? Do you all agree? Now
Yes.
let's put A. If you would have put A before, I can give you a guarantee that these calculations would have become so difficult. So now your task is, these are your A, B and C. Now just do A star into A, B star into B plus C star into C and tell me what answer will you get, and is it matching with what answer we are expecting. We are expecting 2 h cut square. So you only have to do this thing. Okay, so I hope that you can do this and find the answer. If there is some error, find out what error is it and match the answer
20.
with this. Now, okay, and send your solution, very clean solution, entire from up to down. Right, do this question again and find the solution. Okay, my answer is matching. So this is your homework.
Yeah.
Okay. So did you all understood today's session? We will end this here.